Welcome back to this free training series on FEMA P-154, Rapid Visual Screening of Buildings for Potential Seismic Hazards, brought to you by the Federal Emergency Management Agency's National Earthquake Technical Assistance Program. This module will go through part 2 of the Rapid Visual Screening, or RVS process. You're watching the 4th of 9 training videos outlined here. Module 1 was an introduction to FEMA P-154. Module 2 went over earthquake hazard and seismic performance of buildings. Modules 3 and 4 will go over the RVS process. Module 5 will cover key building performance indicators. Module 6 and 7 will go over FEMA building types. Module 8 will be a class exercise, and Module 9 will provide some concluding remarks. So with that, Sarah, please take us away.
All right, welcome to Module 4. We're going to do the second part of the RVS procedure, which includes field screening, so filling out the data collection forms at the site. We're going to talk about the screening process, what we need to do, what we need to think about, scoring for the level 1 and the optional level 2 forms. And then we'll talk briefly about post-field processes and activities, how we want to use this data. So we'll start with the field screening. For the field screening, we're going to want to complete the data collection form. There's 5 sets of forms, one for each seismic region. So that's very high, high, moderately high, moderate, low. And for each of these seismic regions, there's a different set of forms that just includes different scores. There's a level 1 form and then the optional level 2 form. The screening itself is a sidewalk survey meant to be performed in front of the building on the sidewalk, and it should take about 15 to 30 minutes in the field. And if we can get inside, if it's accessible, then we'll do an interior screening, which adds another 15 to 30 minutes to the total screening time. The level 2 screening is optional. It's a more rigorous assessment, and it requires greater expertise and engineering judgment to complete, but it's still rapid and visual. For the field screening, ideally we want the field screening to be performed by a team of 2 people. And this is a list of some nice tools to have while you're doing the screening. So a set of binoculars to capture details on high-rise buildings, a camera. Most of us have a digital camera in our pocket at all times now. A clipboard for holding the data collection form and being able to fill it out in the field as we're walking around. It's really good to have a copy of the FEMA P-154 handbook with you. In particular, Appendix B of the handbook has quick reference guides that provide a lot of information as you're performing the screening and you're not sure which box to check. Having access to those forms is really helpful. And then we need a pen or pencil and a straight edge so that we can complete the form, including a sketch or a drawing of the building. And then if we can get into the interior, a flashlight is really helpful. If we can get above the ceiling to look at what's above the ceiling or into the basement, those are spaces that generally give us a lot of information about the structure of the building, and a flashlight can be really helpful. So FEMA P-154 provides separate forms for the level 1 and level 2 screenings. And on the left, we see the level 1 form, and on the right is the level 2 form. If we're doing the level 2 screening, we need to also do the level 1 screening because that includes all the information about where the building is and who the screener is, lots of information that's necessary. And in the upper right-hand corner of each of these forms, it'll tell you which seismic region it's for. And we get 5 of these for each of the different seismic regions: low, moderate, moderately high, high, and very high. The seismic region is important because it affects the score. So recall that the higher the score, the less likely the building is to collapse in an earthquake. And of course, that is going to be a function of how big the earthquake is. So our scores get smaller as we increase our seismicity. The score is also affected by the score modifiers for, vertical irregularities, all kinds of things that we're going to talk about more in depth. But those scores are here on this form. So the field screening process starts with verifying and updating any building identification information that we might have collected during pre-field screening. So if the pre-field screening said that this is a 15-story building and it was built in 1930, but you walk up to the site and you see a 2-story brand new building, then it's good to update that information so that we know that there's been some sort of mix-up. So we want to walk around the building to identify the number of stories and the shape of the building, and we can create a sketch plan and an elevation of the building. We want to photograph the building and review soil type and geologic hazards. These are hard to review in the field if we haven't been provided with these from pre-field planning. It's going to be hard to identify them in the field, but we can review them to get a sense for what we're thinking about during the screening. As we walk all the way around the building, the full perimeter, we want to identify any adjacency issues, noting any buildings that are next to our building. We're going to be looking to identify the structural system. So what is the FEMA building type of the building that we're looking at? Is it steel? Is it wood? Is it a brace frame or a moment frame? We're going to identify seismic performance attributes. These are our irregularities that we want to think about. And as we collect all this information, we're completing the data collection form, and the end result is a final score for the level 1 screening, which is SL1. So here's a closer look at the data collection form. This is an image of the upper right-hand corner of the form, which is really for documenting where the building is, who is the screener that's screening it, the time and the date. A lot of this information should have been collected during pre-field planning, and now we're just making sure it's correct. Age of the building is a really good one to collect in pre-field planning, because a lot of times that's available from databases, but really hard to figure out when you're just standing in front of the building. In this part of the form, we're going to talk about the occupancy of the building. So the choices here are assembly, commercial, emergency services, industrial, office, school, utility, and residential. Residential can include hotels and motels, as well as houses and apartments. Places of public assembly are those where we might expect 300 or more people to gather. So like a theater or church. This is important information because when we're thinking about our earthquake risk, we might make the judgment that one person in a building is less of a risk than 300 people in a building. We might want to focus on fixing the building that has more people inside of it, more people vulnerable first. So these are not things that affect our score, but they're things that might affect emergency planning down the road, and are a good place to spend just like 30 seconds of time to give ourselves and our community some good information. And then there's some checkboxes for historic, shelter, or government facility. I really think shelter is so important because after an earthquake, we want to make sure that the buildings that are going to be used as shelters are functioning. And then we have the soil type at the bottom. And if this hasn't been completed during pre-field planning, then we want to circle the DNK. Which stands for do not know, and which is going to trigger us to score the building as though it was soil type D. So this is just a little bit below that first part, and it shows, this box shows geologic hazards, so liquefaction, landslide, and surface fault rupture. Again, these are things that are hard to identify in the field, but should have been figured out during pre-field planning, hopefully using maps from USGS. There's a spot for noting adjacencies. So if you've seen buildings that are close to the building you're screening, then we can note that, and we can look in FEMA P-154 for directions on whether it's a concern based on how far away the building is from our building and how tall the two buildings are. There's a place here to document irregularities, so vertical and plan irregularities. And we're going to talk about these a lot in the next module because they do affect the score, and they affect the score a lot. Sometimes you can have a building that would pass, it would get a score greater than 2, but then you have an irregularity and that drops our score down below the cutoff. So these are really important modifiers, and we want to pay careful attention to them when we're in the field. And so this box gives us an opportunity to indicate not just whether there's an irregularity, but what kind of an irregularity it is. And then there's a box for exterior falling hazards. These are some of the most common types of falling hazards that we might see. And we want to note these because they do affect performance, although they will not be part of the final score. So these include unbraced chimneys, parapets, heavy cladding, appendages, and a box for others, because you never know what you'll see when you're out there actually screening in the field. So now we get down to the scores. So this box has the basic scores and the score modifiers for the level 1 form. And the most important thing to identify is the FEMA building type. And then from there, we get our basic score. And the basic score can vary a lot. So these basic scores are based on the high seismicity form. And you can see that, well, let me go to here. Okay, so you can see that they vary a lot. They vary from like 3.6 for a wood, one-story wood building, all the way down to a 1.0 for a URM. So your FEMA building type is going to affect your score a lot. And then the score modifiers are either negative, indicating that something is a detriment to the performance of our building, such as really weak soil, or an irregularity, or it being a very, very old building, a pre-code building. Or they can be positive, indicating a positive attribute that's going to make us feel better about the performance of our building, such as good soil, so soil type A or B, or it being a post-benchmark building, it being built after the adoption of really good, robust building codes. And then the final score, and then we're going to calculate a score based on our basic score plus or minus all those modifiers. And that final score, we never want it to be negative because that's not meaningful. There's a minimum score that we would expect for any given FEMA building type based on analysis that was done to develop these scores. And so if we calculate a final score that's less than the minimum score indicated in the table, then our final score will take as the minimum score. And so this table shows basic scores by seismicity region for a variety of building types. So there's 17 building types, but this table is just showing us seven of our favorite building types to look at for low seismicity, moderate, moderately high, high, and very high. And what we notice is that there's some patterns. So first off, our basic score is higher for low seismicity than for higher seismicities. And that is because our basic score indicates probability of collapse. So the bigger the score gets, the less likely we are to collapse. And the bigger the earthquake gets, the more likely we have collapse. So higher seismicity is correlated with lower basic scores. So if we look at the S1 building type, we have a score of 3.8 in low seismicity, all the way to a 1.5 for very high seismicity. And we can see that the score varies. And if we have the cutoff score of 2.0, which is our typical cutoff score, an S1 building without any sort of modifiers would pass in low, moderate, moderately high, and high seismic regions. because it varies from 3.8 to 2.1 in those regions. And it would fail in the very high seismicity region because it has a basic score of only 1.5 in very high seismicity. We can also see that URMs almost always are less than the cutoff score of 2. So only in low seismicity does a URM have a basic score higher than 2. And wood buildings, conversely, are really well, W1 buildings. These are one-story wood-framed houses mostly. These have really good performance. So their basic scores range from 6.2 to 2.1. So even in very high seismicity, without any score modifiers, a single family home wood structure would pass. So there's 17 building types, which we've alluded to a bunch of times in this module and in previous modules. And we're really going to get into them in an upcoming module. But there's 17 building types, and the building types are based on the material that's used for the structure. So wood, steel, concrete, masonry. And that in conjunction with what type of lateral system we have. So if you recall, we could have a moment frame system, a brace frame system, or a shear wall system. So when we combine material with the lateral system, we come up with specific FEMA building types. So for example, an S1 building is a steel moment frame, whereas an S2 building is a steel braced frame. And these are all laid out. So there's 17 of them in total, and they all have their own different kind of performance and reliability, and some building types are more robust than others. So we have a basic building, we have a basic score dependent on our building type and our seismic region, and we start to modify that based on what kind of characteristics our specific building has. And one of the most important ones is whether we have vertical irregularities or plan irregularities. And these type of irregularities can sometimes make the building less resilient. So they can introduce weak spots into the building. And so they can have a negative effect on the building performance. And based on that, we get negative modifiers for them. And the modifiers, like the value of the modifiers, which can range from like -0.2 all the way up to -2, they vary by region of seismicity and by the FEMA building type. There's also score modifiers based on the age of the building. So pre-code is going to be for buildings that were constructed before codes were adopted. And so the year that pre-code is based on is going to vary a lot by where you are located in the country and when your particular community adopted codes. And similarly, post-benchmark, that is going to be a year when the community adopted and started enforcing a modern building code with seismic provisions. And so if your building was built before the pre-code year or after the post-benchmark year, we get to apply a modifier. And the post-benchmark modifier is positive because it means that your building is newer and was designed for good codes. And so your score increases. And the pre-code modifier is negative because it indicates the building is old and wasn't designed for seismic forces. In addition to pre-code and post-benchmark, the last one we have for modifying the score is based on the soil type. So recall that the basic scores are based on soil type CD, which is the average of soil type C and D. And so if we have better soil, so soil type A or B, then we get to bump up our score. And if we have poor soil, soil type E, we have to take a knock off our score because that's worse for building performance. And soil type F is such poor soil, such unreliable soil that screening a building with soil type F is just outside the scope of the RVS procedure. And so there's no modifier associated with that, but we'll see later that the data collection form sort of kicks us out into a further evaluation if we have soil type F. So in calculating the final score, we have to think about our building and then these modifiers. And so as an example, let's say we have this building. There's a photograph of a one-story sort of strip mall kind of building. And from pre-field planning, we know that it was built in 1990 on soil type C in high seismicity. And that's all pre-field planning information. From our field screening, we've walked around the building, we've taken photos, we've sketched it out in plan, and we can identify the occupancy is a commercial building. It's wood construction, it's building type W2, and it's L-shaped in plan. So if we want to start calculating the score, this is a blow up of a small portion of the high seismicity data collection form. And we've circled the basic score for W2. And then we've circled the plan irregularity modifier because it was L-shaped in plan. So we get a little ding for that. And then because our building is so new in 1990, we get our post benchmark modifier. And it's on soil type C, so we don't have any soil type modifiers. So when we add up those, when we take 2.9 minus 1 plus 2.2, we end up with a final level 1 score of 4.1. And that's more than the minimum score. So we use the final score of 4.1. Now at the bottom of the data collection form, we don't want to just stop with the score, with the final score, but we want to think about some other things. So on the left-hand side of the form is a box for documenting the extent of review. So did we see all 4 sides of the exterior? Did we get to go into the interior? Where we got our soil type source from and our geologic hazards, and whether we performed a level 2 screening. In the middle at the bottom is a box for other hazards. So for example, if we had soil type F or if we had liquefaction, we would indicate that here. And then on the right, finally, is the action required. So there's a lot of different reasons that we might need further evaluation. We might need further evaluation because we couldn't figure out what the FEMA building type was, or because the score was a little less than the cutoff, or because there were other hazards present. And if we know everything about the building and it scored more than 2, then we can check no further detailed evaluation is required. And then finally, we can document whether we saw non-structural hazards and whether we think we need further evaluation of the non-structural systems. So the level 2 screening is optional. It is required to be performed by a more qualified screener. So an engineer, a structural engineer, an architect, or a graduate student studying seismic engineering. We want somebody with who's going to be more likely to understand the building type and the different irregularities. When we perform the level 2 screening, we start with the basic score from level 1 and apply more refined score modifiers to come up with a more, hopefully more accurate score. And it provides further evaluation for structural features affecting collapse risk. So there's questions specific to different building types for the level 2 screener to think about and to apply modifiers for. And it includes a slightly more detailed non-structural hazard screening. So here's a photo of the level 2 data collection form. And again, this is going to be provided for each different seismic region. It requires seismic engineering knowledge to complete the form because Each of the questions on here is detailed, and while the level 1 form tries to avoid technical jargon, the level 2 form does not necessarily. And it provides more, it requires a more detailed evaluation of the kinds of vertical or plan irregularities that you might have. It also includes modifiers for pounding, redundancy, seismic retrofit, and a couple other specific building characteristics that the level 1 form does not include. So recall, on the level 1 form, we just indicate whether pounding is an issue or not. But here we can actually put a modifier on the pounding to come up with a level 2 score that incorporates the pounding. On the level 1 form, seismic retrofit is not considered, whereas on the level 2 form it is considered, and we can get a positive modifier if we have a building that has been retrofitted. And the bottom portion of this has a more detailed checklist for non-structural hazards. These still do not affect the level 2 score, but they're provided as a place to document hazards that might be observed. So when we're calculating the level 2 score, we start by transferring the score from level 1. We use that as the baseline. We get rid of some of the modifiers that we applied in level 1, and then we have a new score, and then we apply level 2 modifiers to it to come up to an adjusted level 2 score. And there's a cap on each of these, just like on level 1, we had a minimum level 1 score. Here we have a cap on vertical irregularities. So in level 1, if we have a vertical irregularity, it's the same as if we have 1 versus 2 versus 3. We only apply the irregularity modifier once. Whereas on the level 2 form, the irregularity modifiers for each kind of irregularity are slightly smaller, but we can add them together. So then we want to cap it at a certain point. And we'll have an example a little further on. And then in the middle half of the form, we have specific questions about different kinds of building types. So for example, for manufactured homes, there's a supplemental, there's a place and an opportunity to indicate that the manufactured home has supplemental seismic bracing provided between the carriage and the ground. So that's where we most often see manufactured homes or mobile homes fail, is between the bottom of the manufactured home and the ground. And so if we can observe on the site that there's bracing there, then we can apply a positive modifier, bring that score back up. And like I already mentioned, there's a more detailed non-structural hazards checklist that allows us to document more thoroughly what the non-structural hazards might be. So in level 2, we are able to consider multiple plan and vertical irregularity conditions. So recall in the level 1 form, if we have several different vertical irregularities, we're just concerned about whether we have one that's severe or if they're all moderate, and we take the score based on that. And for plan irregularities, we're just concerned about whether we have one or not whether there's multiple or how many. But in level 2, we're able to refine that. So for example, let's say we have building type C2. And we're in high seismicity, we have a reentrant corner plan irregularity and a diaphragm opening irregularity. So those are two different plan irregularities, and the reentrant corner is going to have a bigger effect on our seismic performance than the diaphragm opening will. So in level 1, the score modifier for plan irregularity for a C1 building is -0.8. And in level 2, when we take that plan irregularity, we're going to think about what actual plan irregularities we have. So for the reentrant corner, we get a score modifier of -0.4. And for the diaphragm opening, we get a score modifier of -0.2. And now we're going to add those together and get an actual final plan irregularity modifier of -0.6. So in level 1, we had a modifier of -0.8, and in level 2, we have a modifier of -0.6. So the modifier is reduced. Our score is actually a little bit better than we thought it was when we just did the level 1 screening. Conversely, for building type C1, the level 1 plan irregularity modifier is -0.5. And when we look at level 2, for the reentrant corner and diaphragm opening, we're going to end up with -0.4 plus -0.2 is -0.6. So our modifier for plan irregularity is actually higher now. So the idea is to get a more accurate score, and most of the time that will result in a better level 2 score because we're taking out some of the conservatism. So usually our level 2 score is higher than our level 1 score, but not always. The irregularity modifiers, because they're cumulative and we're adding them together, there is a cap on the level 2 form so that we don't add too many of them together and get an overly conservative resulting score. So what do we do after we've done all these screenings? Well, we're going to finalize the data collection forms and the scoring forms. We really want to perform some QA/QC. So we're going to look at, did all the forms include a picture? Did they do the irregularities indicated in the basic score? Do those reflect like the photos that we saw? And we might, want to do some quality control on like different sets of screeners. Like we might notice a lot of errors in a certain screener's data. So we want to do some QA/QC and kind of identify where there might be trouble, where we might want to do some further review. And then we're going to file all that screening data to make it available so that in the future we can use that data to evaluate and rank seismic retrofitting needs. So take all the buildings that got below the cutoff and do further evaluation of those if necessary. We can use this data to develop seismic hazard mitigation programs, develop vulnerable building inventory. So for example, if we want to know where all our URM buildings are in our community, perform earthquake damage and loss impact assessments. We can input this data into hazard mitigation plans and HAZIS. We can develop post-earthquake building safety evaluation plans, and we can develop seismic vulnerability information. So this data is going to be really useful for a lot of different activities, even more so than just like figuring out what buildings specifically we want to do further evaluations on. We can really use it for a lot of mitigation programs. All right, we've made it to the quiz question. The question is, what factors affect a building's level 1 RVS score? Building adjacency, building additions, non-structural components, vertical and horizontal irregularities, or all of the above? And please take a moment, pause your video, and think about what affects the building's score. All right, Gigi, do you have thoughts?
Yes, so while these all affect the building's seismic performance, only vertical and horizontal irregularities will affect the score.
That's right, because during the level 1 screening, we want to document building adjacency, whether there's pounding and additions and any vulnerable non-structural components. But those are just documented. There are no score modifiers associated with those. So only vertical and horizontal irregularities will affect the level 1 score. On the level 2 side, we do have a score modifier for building adjacency for pounding. So that could affect the level 2 score. But correct, vertical and horizontal irregularities are the big one that affects the level 1 score. All right, we have time for a question.
Awesome. Okay, so what is the difference between the pre-code and benchmark modifiers?
So the pre-code is really meant to capture a building that might have been designed and constructed prior to the adoption of seismic codes. So when we have a really old building, the designer might not have been considering seismic forces, and so we wouldn't expect very good seismic performance, and hence the probability of collapse would be higher. So that is a lower score. So the pre-code modifier lowers the score. It's a negative number. Whereas the post-benchmark modifier is applied when we have a building that was designed and constructed after the adoption of modern seismic codes. Codes that really capture kind of the performance that we would find acceptable today. So when we have newer buildings, we get to apply a positive modifier to the score to capture the better performance of that building.
Thank you. Who can do a level 2 screening?
So a level 2 screening is supposed to be done by a structural engineer, an architect, or a graduate student with a background in seismic evaluation of buildings. And the reason is on the level 1 form, the questions and the score modifiers, they're really meant to be not subjective. Like it's either yes or no, and there's guidelines in FEMA P-154 for how to answer those questions and determine whether your irregularity meets the criteria to get a certain score modifier. On the level 2 form, the questions are more complicated. There's more engineering jargon associated with them, and they require some engineering judgment to identify whether it's appropriate to take a score modifier or not. So the level 2 form is meant to be more accurate, capture more of the characteristics of the building, and it requires more engineering background and seismic background.
All right, so in the next module, module 5, Mike will take you through key building performance indicators. This includes building additions, building adjacency, irregularities, and non-structural components. This concludes training module 4, Rapid Visual Screening Procedure Part 2. We'll see you in the next one.